Good afternoon, everybody, and welcome to today's webinar. My name is Cheryl Jennison DeProza, and I'm joined by Chris Lyons. And today we're going to be talking about advanced frequency coordination techniques using our Wireless Workbench 6.12. That's the new version that's coming out. And we are joined by two very, very special guests that are going to talk us through and walk us through and show us all the great things that that Wireless Workbench can do. And that is Sam Drazen, who is the software product manager, and Ilya Traeger, who is the senior software engineer here at Shure, one of our senior software engineers here at Shure. So they're going to talk us through all the ins and outs. But before we get to that, just a few quick items of housekeeping. This webinar is being recorded, so if you ever want to view it in the future, you can go to shure.com/training. All of our archived webinars are located there. There's a lot of great topics covered, a broad amount of learning from beginner to advanced. So please feel free to take time and view it. It's all free. It's all available at the click of a mouse. Shure.com/training. This webinar will be available probably sometime next week there. And then the second item is that if you have any questions, please feel free to type those in the upper right-hand corner of your screen in the question pane. If you don't see that question pane, just look for a little toolbar with an orange box that has a white arrow on it. Click on that white arrow. That will maximize it and give you access to the question pane. We will answer questions at the end of the session, so please enter in your questions. But be patient. We will get to as many of those as we can at the end. So that wraps up all the business that I have to talk about. Let's get into the good stuff. Take it away, Chris.
Thanks, Cheryl. All right, welcome everybody. And today we want to talk about RF coordination. And we should probably say at the outset, a lot of our webinars are fairly basic for people who are new to microphones, new to mixing, new to whatever. This one's a little bit different. We're going to be talking about advanced frequency coordination techniques. So we're assuming that everyone listening already knows about intermodulation distortion, already knows about frequency separation and that sort of thing. If you're not already comfortable with some of those concepts, you might want to look at some of our previous webinars where we talk about basic frequency coordination and so forth. But today, Sam and Ilya are here to talk about some new features of Wireless Workbench and how they are really useful for frequency coordinators who have to really push the boundaries a little bit. So Sam, tell us what are we going to talk about today?
Thanks, Chris. I think to set a nice foundation, we might briefly discuss the goals that an RF coordinator might have, that the position is new, is indicative, or that there are so many needs for frequency coordination tasks. I think speaks to how much RF coordination has become a more popular practice in large-scale productions where wireless microphones are a critical source for audio. So we'll briefly discuss the goals that a professional RF coordinator might have, only to set the stage for discussing some of the tools that might be in their toolkit, and then discussing some frequency coordination techniques that pertain to atmospheres where a high channel count is needed to just get a lot of wireless channels online. And that's going to lead into a demo that we'll do where we'll spend the bulk of our time showcasing some features of a Wireless Workbench 6.12 that has a lot of features specifically targeted towards frequency coordinators who need to get a lot of channels on air.
Mm-hmm. Great. All right, well, let's go into a little more detail. So what are RF coordinators doing? And we should say that this used to be something you only found at a big event like the Olympics or the Super Bowl, but now it really is, you see frequency coordination services at big trade shows, at music festivals, for big educational campus wireless installations and all sorts of things.
Yeah, it's the role of RF coordinator, like you mentioned, can be seen in small music venues or bars. It can be seen in houses of worship or corporate installations, pretty much anywhere where people want to expect their wireless audio systems to work properly. And not just audio systems, but a lot of things that leverage RF to transmit data. So the goal of an RF coordinator, and the reason the position is so much more popular now today than it was, is because it's making wireless work. While that might be their goal, it's not necessarily always easy. A lot of things use use RF signals to transmit information, and coordinating all of that data is not always a trivial task. So the first goal of an RF coordinator is to make sure that wireless systems work. It's kind of an obvious thing, but that often entails a number of tasks, not the least of which is finding compatible frequencies. This is literally the real estate in the spectrum in which frequencies would occupy to not interfere with one another and also transmit cleanly in the spectrum. A big piece of finding compatible frequencies is properly accounting for your RF environment, understanding whatever spectrum range your wireless systems are operating in, what occupies that spectrum when your wireless microphones aren't there. Properly capturing scan data and properly surveying, the RF environment. So you understand the dynamics of are things coming in and out and transmitting in that particular spectrum? Is it relatively low noise? It just gives you a better grasp of what you need to do to plan effective wireless usage there. And then like any audio professional or any professional of a technical sort, things don't always go properly. There are issues with wireless systems. The RF coordinator's job is to not only have backup frequencies coordinated for their systems, but also just have fail-safes in place so that if something goes wrong with their wireless systems, they've got a plan in place to recover and make sure that they can get the systems back online. A topic we're not going to discuss today in particular, but a key piece of an RF coordinator's responsibilities is also to understand and optimize RF signal flow, getting RF data either out through antennas or into antennas and making sure that all of the disparate components that need to receive an RF signal are getting properly conditioned and at a proper level, the RF signal from their transmitters to their receivers. It's not really pertinent to frequency coordination, at least what we'll discuss today, but it's a critical part of configuring wireless.
We're kind of already assuming that that's been done right.
Yeah.
At this point. And I think we had a webinar maybe a year and a half ago all about antenna placement and selection and optimization. So
Shure.com/training.
Thank you, Cheryl.
No problem.
All right, well, let's jump right into it. So what kind of tools are frequency coordinators using to get this done?
A basic arsenal of tools might include something like a scanner or a real-time analyzer, something to listen to the spectrum and to give a visual indication of what things are transmitting, what things are operating in the spectral range where your wireless systems might be. We also see more and more frequency coordination software being a part of a coordinator's toolkit, software that can take into consideration a number of different factors like the systems that you might be using, the bandwidth that they can tune to, relatively how much personal space they might need in the spectrum, and then some other attributes that let a series of calculations be performed to find an optimal combination of frequencies for all those systems, such that they don't interfere with one another. And so Wireless Workbench is a key example of that we'll get through in just a minute. But in addition to finding frequencies for your wireless systems, device monitoring and control software also is pretty helpful to deploy that configuration to your wireless devices. I'm sure it's got a big portfolio, and a lot of other audio manufacturers have the same sort of portfolio of network-controlled systems, which make it really easy to send data to your gear instead of having to bend over and, with a punch, with an encoder and buttons on the front panel of every device, set parameters. Where if you're just setting 2 devices worth of frequencies, it might not be so bad to do it by hand. But 200 channels gets a little bit more cumbersome. So that's where control software kind of comes into the picture. And then last but not least, just a general knowledge of the spectrum in which your wireless microphones operate. If you're running wireless systems in the DECT range versus the UHF TV bands, the wireless properties of systems that operate in each range tend to differ. So a general awareness of the law, the rules of the road, so to speak, of the spectrum ranges that your systems operate in is a pretty important baseline.
Mm-hmm. And just to be clear, if there's anybody here who's not familiar with how this works from a scanning point of view, Wireless Workbench isn't the scanner per se. That's an outside piece of hardware that does the actual tuning and listening. Wireless Workbench just lets you analyze and process that information.
Yeah, that's a great point, Chris. Wireless Workbench is excellent at capturing scan data using a Shure networked device like a networked receiver or Axient Spectrum Manager. And it can also import scan files captured from a TTI device or an RF Explorer, a variety of other third-party scanning devices. But it itself is not a scanner. It is merely a scan processor that can turn that information into useful inputs to coordinate frequencies.
Right. Great.
Yeah, that's
okay.
a good clarification.
Let's talk about some of the basics, the boilerplates of the approaches, the techniques that people can use.
Yeah, so what we'll do today, and I think the demo is going to cover this better than text will, is we're going to walk through sort of 3 key steps RF coordinators can do to best find sufficient frequencies for their systems. And the theme of today is going to be being appropriately aggressive to find enough frequencies for high channel count applications. The first one, as we mentioned with scan data, is to just understand your environment. Typically, scanners will be used to listen across the range of the operational spectrum you plan to use and show you where the noise is. And it can come from any variety of devices, including, but not limited to, audio wireless systems, video walls, intercom systems, anything of the sort that might be wireless or not. After you've assessed your wireless environment, the next thing that we'll talk about is classifying the devices that you're going to be using. If we're rolling into the United Center in downtown Chicago and Ilya and I have 20 wireless channels we're going to use, it also might be the case that the United Center has their own wireless systems. And we want to make sure that we're not only getting good wireless performance out of our gear, but that we're good citizens and aren't stepping on the frequencies that might be there in the house. And that same sort of concept of understanding the full landscape of not just your gear, but all of the gear in play from a wireless perspective is another thing we'll cover in a little bit of detail.
Good.
And then last but not least, just tailoring coordination settings. This is where some of the new features to Workbench 6.12 come into play. Really being appropriately aggressive is, I think, the way I like to say it, to fit the most frequencies in the least spectrum as possible. And given the spectrum landscape and how things are changing with regulatory changes and increased RF efficiency of systems, this is something that you can really leverage well if you know the right sacrifices to make.
Mm-hmm. What's that old saying that the definition of an expert is not someone who turns a screw, but someone who knows which screw to turn.
There you go. I like that.
And that's what frequency coordination is all about in this case, is knowing which levers you can pull to squeeze more.
That's exactly right.
All right. Well, let's see. Let's push a couple of buttons here and shift over so that we can see Sam's screen here. And there we go.
So what we're going to do today, I'll just give a quick 1 minute background, is we're going to give a shallow dive through Wireless Workbench 6.12. I just want to come right out and say 6.12 is not available yet. It will be available very soon, in the summer of 2016. In fact, we're looking about in the next couple weeks. But we're giving a preview today of 6.12. Only a very small subset of the features are we actually going to discuss today. The release has a ton of new functionality, but today we are explicitly going to be focused on frequency coordination for advanced RF coordinators. And you see on my screen I've got a boatload of Shure gear that we're going to do some coordination tasks for. But first, what I want to do is just set the stage. Sort of going back to the workflow that we just talked about, Chris showed a slide with 3 main steps of getting set up for frequency coordination. The first step being classifying your RF environment. Now you'll notice that I've loaded a scan file in here. If I was connected to some Shure network devices, I could capture a live scan too. That's a feature that we offer with our networked wireless systems. But in the time being, I'm just going to load a scan file that was taken with a spectrum manager. And you'll notice that it ranges, if I zoom out here, from 470 to 952 megahertz. But one quick thing I'll show, which is kind of cool, is that the 6.12 version of Workbench I'm showing actually supports scan data from all the way down to 30 megahertz up to 2 gigahertz or 2,000 megahertz. So if you had a third-party scanner or some device that could capture it and store that scan data in a CSV, you could import that scan into here and coordinate frequencies for VHF systems, stuff above 1 gig, basically any system within this range.
Mm-hmm. And now that's more and more important because more frequency bands are becoming available in typical wireless gear, so it's more likely that if you're running a lot of systems, you're going to be integrating a whole bunch of different frequency ranges.
That's exactly the case, especially in different areas around the world. Different spectrum ranges are being sold off or being repacked, and we wanted to make sure that all the flexibility our customers were used to having in the UHF TV bands extended beyond for alternative ranges.
I would like to add a little clarification. Everything is correct about 30 megahertz all the way up to 2 gigahertz. However, just remember, if the system behaves like your typical UHF system, then this calculation and coordination is applicable. If you have a digital device that hops frequencies, operates on its super low transmissions, this calculator is not for those devices. Just an example, DEC devices are not subject to this type of coordination. Some smart devices can figure out their frequencies on their own. And again, those are not subject to this coordination.
That's a really key point. The calculator in Wireless Workbench is for fixed frequency, single carrier systems. And that is sort of a foundational, that's kind of the way it's always been for Wireless Workbench calculator.
Exactly.
Yeah, that's a good point. That's a good point. So kind of just jumping into 6.12, I'm going to zoom in and showcase one new feature that pertains to the first element of our workflow, classifying our RF environment. So if you're looking at this scan, you'll probably see some similar fixtures that the scan data presents, DTV stations that have these very common, at least in the United States, 6 megahertz humps. And we've got some scan peaks over here. You'll notice that this red line, which has always been there, it's our exclusion threshold, is the user's control to set their threshold for pain, being noise, RF noise from a scan above that line excludes the spectrum for which the line is surpassed. What is new to 6.12 is the fact that we are displaying this secondary threshold, this orange line here. And it might seem mundane, but just you wait. It's about to get real exciting here. This new threshold is a scan peak threshold. And functionally, what it's doing is nothing new from previous versions of Workbench. Wireless Workbench 6 has always had this functionality, but what we're showing in 6.12 is that this threshold is there. And it behaves a little bit differently from the scan peak threshold. Ilya, maybe you can explain how it works.
The orange threshold is something new and something old at the same time. It always existed but never been visible. However, we felt that users want to have more control over how they deal with frequency coordination, so now it's totally under your control. It has some logical limits. You can drag it all the way down below the red one. It will always remain above it, but its default value is carried over from the previous releases of Wireless Workbench. And what it means that any signal that pretty much sticks out, meaning being hot power-wise, is treated as something dangerous to you because it can create intermod products, and basically it's something to be aware of, stay away from, and possibly not to interfere with it. This is going back to what we said in the introduction. Being a good citizen is protecting your interests, but also be cordial to your neighbors.
Yeah, so what does this mean? Why are we doing this in the first place? Well, if I were to have captured this scan, and a scan peak like this were to have existed in the environment that I was going to operate my wireless mics, if I wanted to be polite to what looks like an RF transmitter of sorts, a handheld microphone or something like that, I probably wouldn't want to get too close to this scan peak. It probably represents another wireless system operating. So the way that Wireless Workbench handles this scenario, by default, it's been built this way, is to assume that there's a device here. And not only is sort of that assumption has a couple things tied to it. One, we're going to avoid just this blatant spectrum for which the scan goes above our exclusion threshold. But two, what we're going to actually do is assign an equipment profile, similarly to like what you would assign for a Shure UHFR or any system you would add to your inventory, that defines some spacing parameters that will protect this particular frequency. And I'll actually show you a secret feature. It's not in the released version, but I think it's helpful for educational purposes to actually see what sort of channel spacing we give around this peak. So by default, Wireless Workbench doesn't pretend to know what sort of system is there. It associates a very generic profile. That's what we used to call it in previous builds, a generic profile. But what we call it now, it's been updated the name to generic device. And all we're really saying here is we know there's some entity with a high output power as received by the receiver at this frequency. Because we don't know what's there, we're going to assign this generic profile that makes sure that no other frequencies that Workbench will coordinate get close enough to this signal such that it would interfere with it. So in general, it's a good way to protect and to be a good citizen to peaks around your vicinity.
So the standard scenario is, I don't know what it is, but I'm going to be nice to it.
Exactly. That's a great way to think about it. And when you're being a friendly neighbor in the RF spectrum, that's a great way to operate. However, where that can sort of turn against you is if things that are transmitting are either not authorized to transmit there, or there shouldn't be anything there and you don't know what it is, or you have such high frequency count needs that you don't have the luxury of being a nice citizen. That's where having this generic device profile associated with the scan peaks can slowly start to eat up more and more of the available spectrum that you might have used otherwise.
So if you start being nice to all of these rogue signals, pretty soon there's no room for your signals.
That's exactly right. Now, some signals are pretty cut and dry. This looks like a wireless microphone here on our screen, but if I zoom out, you'll see that it's not hard for other things, like the leading edge of a DTV station, to trigger that scan peak threshold as well. Now, you saw, I'll turn this thing on again, you saw what wide berth is given to scan peaks. You know, it's an 800 kilohertz channel spacing. Actually, in our equipment profiles dialog, which all of the profiles that Wireless Workbench uses, they're defined in this dialog. You can see that 800 kilohertz on either side of a generic device is given, which is a pretty wide berth, meaning no other carriers can get anywhere within 800 kilohertz of that carrier. Now that's kind of a heavy-handed thing, especially for a DTV leading peak where we know that's not going to behave the same way. It might not cause intermod. products or
It's not real subject to being interfered with by us either.
yeah, we're the ones who need to worry about that, not
Right.
the other way around. So what we've done in 6.12 is not only show that we've been coordinating these scan peaks, but give the user flexibility to change them quickly. And we've added a couple different profiles by default that are available that better let the user better classify what those things might be. And they're all available in a right-click menu if you right-click over this rhombus. And this rhombus is a new symbol to Workbench 6.12. All it's signifying is that this is a detected scan peak. Now, there's a little bit of nuance to what those how you can classify one of these scan peaks. You can call it a generic device, which is basically a profile that has a channel spacing, meaning that the frequencies that we coordinate will be respectful of a channel spacing that's associated with this generic device. And then within that, there's sort of two flavors. There's an IMD flavor and a no IMD flavor. And all this means, if I were to change it to no IMD, you'll notice that the rhombus goes hollow. And this is just a way for us to symbolize that this particular peak, while we want to avoid getting too close to its channel-to-channel spacing, we're not assuming that it's going to generate further intermod products with other systems that could generate intermod products. So this might be a way we'd want to avoid it. Or if I don't really want to give this thing a channel spacing protection, I just want to avoid the frequency dead on, I can use the generic exclusion profiles, which have no spacing. As you can see, the channel-to-channel skirt goes away, but the dead on frequency will be avoided as well.
So the order of those profiles that you saw right about now, it's from most conservative down to the least conservative. At least I'm talking about the upper four options. And the fifth option is something totally different, but general rule of thumb, if you want to be conservative and protect the channel, you go with the first one. If it's totally something you can ignore and still operate, you can go all the way down to generic exclusion, no IMD.
Just some other flavors. So taking a step back, we are showing you tools that help you best classify peaks in the spectrum. And this is valuable just to make sure you're taking the right considerations with a noisy RF environment. But there might be cases where all of this is too conservative. You need so many frequencies that you want to make a blanket statement about how scan peaks are assessed in the spectrum. And so for that, what we've added is a preference to say, by default, what do you want Wireless Workbench to classify these scan peaks as? And so as you see, we've got the most conservative one selected, which is functionally equivalent to what our current Wireless Workbench does now and has always done since its launch. But what we've added is the ability to let the user either turn this feature off wholesale, pick one of these four profiles, all of the spacings for which you can see in the equipment profiles dialog, or for that matter, choose your own. So what you could say is, I don't know what these scan peaks are, but I'm going to make the assumption that anything I encounter out in the wild will be roughly as robust or need as much space as a UHFR. And it'll take the spacing parameters for that and automatically apply that to those systems. Or what we would recommend is to create your own version of these generic profiles that are probably a little more aggressive. 800 kilohertz channel spacing is pretty ridiculous. But in any event, what I can do is I can choose to call all of the scan peaks generic IMD exclusions. And actually, before I do that, what I want to do is bring in frequencies to the frequency calculator. And I want us to calculate frequencies for a pretty large rig. I think we have, 100 and something? 144 frequencies. And as we make these tweaks, we're going to keep calculating more and more, and we'll hopefully see the amount of frequencies we've found versus those that we've asked for, which is summarized in the bottom right-hand corner there, slowly increase as time goes on. So you'll notice that we found about 61 out of 144 frequencies, far from what we really need. And you're seeing our frequencies dance around here. You'll notice that the markers are color-coded per their color coding in the inventory. This is a new feature in 6.12. I just went by system by band, so each color is either UHFR, PSM 1000, and then probably a different band. Just a little bonus feature there. So I'm going to stop this and show you what happens if we take all of our scan peaks and instead of treating them as generic device IMD, let's treat them as generic exclusion IMD, which says that we're going to get rid of that 800 kilohertz channel spacing on either side of those carriers and see how many more frequencies we have if we're not taking into consideration those channel spacings. So we found a couple more, but still, the spectrum hasn't completely opened up yet. And now that I'm looking closer, I realize that all of these leading TV edges are still scan peaks that we're considering, which might be an unnecessary assumption for us to take. So I
In
could,
most cases, we would just consider, well, that's part of the TV signal. I'm already avoiding that, so unless the peak is abnormally large, I probably don't need to really consider it as a peak, right?
you're totally right. And you could do that a couple ways. You could raise the threshold if you wanted to be less sensitive to noise, or what a more sort of surgical way to do it would be just to ignore or to delete all of the exclusions all of the peaks that were detected that correspond to TV stations. And actually, I'm going to hide markers just so it's a little bit easier to see what we're working with here. So just by right-clicking and ignoring all the peaks that are obviously a part of the leading edge of a DTV station, we'll open up a little bit more spectrum and reduce the intermod products enough such that we should be able to find more frequencies. And we've added about, 4 or 5 more to our, there we go, we're finding upwards, almost halfway there. So you'll notice, or if you've used Wireless Workbench in the past, you might have gotten to the stage where you found some frequencies, but not anywhere close to what you actually need to find. And that's the thrust of sort of the next feature that we'll be talking about, which gives even more power and flexibility to take some assumptions to best fit a lot of frequencies in. So we're talking a lot about intermods. Intermods being the resonance of multiple frequencies such that they create these mathematically predictable subcarriers that can interfere with other wireless carriers you might want to coordinate. The best view to really see how these values, what these values are and how they might interact with is in our equipment profiles dialog. Per system, this table shows you what the calculator considers the channel spacing for a given system and then the IMD spacings from 2-tone third order all the way down to 3-tone third order. And these profiles, the ones that we provide are non-editable, but you can create custom ones too that define third-party systems or are more aggressive for Shure systems as well. Now these are fixed, as I said, for third party or for the ones that we provide in our database. But sometimes, if I'm calculating frequencies for all these UHFR systems, I need to find 24 frequencies for each one of these bands, and Workbench isn't finding them for me. We've added this compatibility tab to the right sidebar of the calculator, and what it shows us when we select a frequency header. Just by the way, to be 100% clear of what I'm showing here. If I expand all this, you'll see each one of these headers corresponds to a list of frequencies that I'm calculating. You see we haven't found everything yet. And all I'm doing to get a better view top down from everything is collapsing that so we can see. I just wanted to call that out. So you'll see when I select any one of these groups of frequencies, we get a summary of the compatibility preferences that are currently being used in the calculator for this group of frequencies. We've got this standard compatibility profile, which is one of 3 settings Shure provides to say, how much personal space do you need? A lot of personal space, which is like robust, that would give you a high quality frequency or a very compatible frequency, versus more frequencies, which is more aggressive. Less personal space, more quantity of frequencies.
Sometimes it's easy to think of this personal space as the seats on the airplane. In the first class, you get wider seats, more space, more legroom, and obviously in the rest of the plane, you get less. So we got 3 types of seats for the wireless workbench, and for bus is the best, of course.
That's a great analogy, a really good way to describe it. And beyond that, when you select a compatibility profile, what we're now showing down below are the channel to intermod spacings that we just saw in the equipment profiles dialog. The difference being, though, that now we're providing users the flexibility of temporarily disabling intermod spacings for certain systems. And I'll show you what the impact of that is right now. So what a user might typically do in Workbench today is use the more frequencies spacing. And by doing that, you can see the IMD spacings corresponding to PSM 1000 and the G10 range update channeled to 3-tone third order drops off. But if I go to, let's see, UHFR, each one of these has a 50 kilohertz 3-tone third order spacing. What I can do is ignore that such that it's 0. So by unchecking this checkbox, what I'm doing for all my UHFRs is saying that when I synthesize frequencies, I'm assuming that three-tone third-order intermods are not going to be generated, and I'm not worried about being susceptible to other three-tone third-order intermods. And you'll notice from 71 frequencies, just that brief change has a little bit of an impact. I think what might be just as impactful too is if we were to reduce the channel spacing to 175 kilohertz as well. And we're squeaking out a couple more, not so many. I think these PSM systems in the same band are what's taking up a lot of space here. So like any frequency coordination exercise, it's a lot of massaging and trying to understand the right sacrifices that you can make. And I think having a clear understanding of the physics of why intermod products are created are key to knowing what intermod products you can turn off. For microphone systems, it's pretty clear cut that when transmitters are close enough to one another in proximity, that is when the intermod products are a lot more likely to be created. So if you've got two transmitters in close proximity, your guitar player and your bass player are back to back, shredding some awesome solo. The proximity of their body packs is a factor and something that could create intermods that could be harmful to other carriers. Which is why we seldom want to ignore two transmitter third tone intermods. The likelihood of two transmitters being close to one another is highly likely, and something that it would be a little bit risky to ignore.
So basically, the system is sort of thinking along the lines of the worst case scenario, which is that, well, these two people are going to be standing right next to each other, or these three people. And you might know as a show coordinator that, well, that's not going to happen. This person's going to be over there. This transmitter is going to be over there. They're never really going to walk together. So you might be able to say, oh, you know what? I can say, don't worry about that happening.
That's exactly it. And I think if you know some key things about where the systems are going to be, you can make a few parameter changes in Wireless Workbench that greatly relieve the calculator from trying to fit so many frequencies in one space. A good example of that would be like two stages in a music festival. If stage A and stage B are 1,000 feet apart from one another, what that knowledge can do is inform the calculator that the proximity of these systems is so far away that the likelihood of intermod products is effectively zero. And that relieves the calculator from considering any intermod spacings. We have a feature called zones, which we use for that. And the way that you set that up, let's assume that, let's say our PSM 1000 J8s and our URG1s are both operating in that stage B, or zone 2, the secondary zone. What I can do is I can move them to zone 2. And you see zones, I already got some L3 holdouts here. Let me just remove these guys. The zones are represented in tabs in this interface. And each zone represents effectively a disparate geographic location. I don't know if we have a hardcore requirement on how far geographic locations mean.
There is no such number that we would like to give you, and it's totally left to your expertise and experience. But generally, the thing to consider is, are your system far enough that the intermod products from one installation or venue wouldn't get all the way across whatever distance into another one? And knowing that intermods are lower than your main power, it's pretty much a call on the spot. And generally, you can think how far your transmitter transmits and cut it by far at half or 4 times, and then you decide whether the other spot is called the zone.
So we're definitely not talking about 2 adjacent meeting rooms at a hotel, but maybe 2 stages at a festival, or 2 venues at a theme park or something. Those might be completely different zones.
Exactly like that. Frequencies in different zones will have no affordance for intermod spacings bleeding on top of one another. The only thing we're going to protect for are direct frequency hits and channel-to-channel spacing.
And in my experience, judging by the questions that come my way sometimes, it's a common mistake when people try to use zones as the means of organizing gears in racks or rooms. And as Chris said earlier, adjacent rooms do not qualify as different zones. They're definitely the same zone because their ref environment is identical in both.
Yeah, that's a great way to say it. So just as I put those frequencies in different zones and tried another calculation, you saw our number jumped all the way up to 123 frequencies. And that's with these profiles in the second zone being standard. If I wanted to ignore three-tone third-order intermods for P10s. I probably wouldn't do that if the transmitters are all in the same rack, but I could lighten that down. Oh yeah, still the three-tone intermods are dropped there, but I can get more aggressive in each one of these zones. And now the restrictions for each are significantly reduced such that we're almost at our 142 limit. So by merely understanding and acknowledging that certain systems are going to be spaced far enough apart, we've greatly relieved the pressure on the calculator of fitting so many frequencies in the spectrum. So it's a lot about understanding just the constraints you can take. And I think zones is a feature that a lot of people may have used organizationally just to sort of group this conference room, that conference room in Wireless Workbench in the past. But understanding the intermod implications, I think, are a key part of getting the frequencies that you're looking for.
Mm-hmm. Now, is there a feature in the new version of Wireless Workbench where I can click on something and it'll send a note to the producer of the show saying, I really think you're being unreasonable here. You're asking for too much.
You know, that's a feature, Chris, we're going to have to push off, I think, until a further release. But
6.13.
So one other point I just want to make about this intermod turning on and off business is that it is a feature that is potentially very dangerous. You know, if you're ignoring two-tone third-order intermods for systems in the same zone and you've got transmitters right on top of one another, you're setting yourself up for chaos there. But this is a webinar for advanced frequency coordinators and a feature for those who are savvy about the implications of intermods. So us including this in Wireless Workbench, I think, really is a testament to us, our desire to better serve that elite tier of coordinators who knows what they're doing and, as you mentioned, knows the right screws to turn in order to find, oh, hey, look at that, 142, to find the solution that we're looking for.
There we go.
Yeah. So this is, at a high level, we showed how you can ignore certain intermod products for certain systems and how the use of zones can sort of take that functionality to a higher level so long as you understand geographically how your gear might be dispersed.
Mm-hmm. And also managing the different types of peaks that you have and figuring out how you want to treat those peaks is interesting too.
Yeah, the only other feature that I would call out as a part of 6.12 with regards to frequency coordination is one for coordination order. Doesn't seem like too fantastic of a topic, but it is quite a flexible thing if you know how to use it. The coordination order is the term we use to refer to which frequency requests are fulfilled by the calculator and in which order. So if you had two types of systems, one type of system that only had maybe two possible frequencies it could tune to, a PSM system from the 90s or something like that, and then a wireless microphone system more contemporary, maybe that could tune to several thousand frequencies. You would want to find frequencies first for the systems that have the least flexibility. Mm-hmm. We refer to this as a coordination order determined by agility, and it is the default coordination order that Wireless Workbench has always used. To feed the pickiest eaters first, I guess, is a good way to think about it. But a feature that we've introduced in 6.12 gives users a little bit more flexibility in an ad hoc sort of way to customize the order in which frequencies are found. So just in this view right here, if I knew that my money talent was using the UHF H4 frequencies, I could just drag that group of frequencies up to the very top, and what that would do would fulfill those frequency requests first, deprioritizing everything else afterwards. Doesn't mean that I'm not going to find everything I'm asking for. It just determines the order in which frequencies are fulfilled.
Does that work just for an entire band grouping like that, or can I do that on an individual unit basis?
It's a great question. At the present, we can only organize groups of frequencies at a time, and that's just because of the way that the calculator is architected. Although if you did want to get more customized with the way that you order groups of frequencies, you could utilize a feature called inclusion groups, which has a special sort of customized bin. You can put certain frequencies one by one channel in an inclusion group, and then that becomes a separate bin that you could organize. There's actually a wonderful set of tutorial videos that the golden voice Chris Lyons himself has even talked us through.
I knew that sounded familiar.
Yeah, that you could check out, and that's on our forum and I believe on the webinar page as well.
A little technical detail that you may find useful later would be this. As you saw, you can change the coordination order right there in the coordination space. However, just remember that that order will be maintained for as long as this session of Wireless Workbench is going. Once you quit Wireless Workbench without saving any files, you load things back into the same fashion, and this change will be gone. So if you want to preserve this coordination order that you customized in the coordination space, you save either entire show file or you save your coordination workspace. Then you can load them back and get your order exactly the way you left it. Otherwise, the default order that Sam is currently showing you will take precedence.
And if you, in your experimentation, found a coordination order you thought that's the way I want to do things from now on, or I want this to be persistent, you could just change the preferences to reflect that order. And then from there forward, that would be the default coordination order. So it's a highly flexible thing. 6.12 merely adds an ad hoc, just-in-time adjustment capability for the user right in the coordination workspace.
Okay, interesting.
So that's just a quick recap. We talked about more accuracy and fidelity in classifying scan peaks with a shortcut menu to use one of 4 of these default profiles that we've created, as well as associating custom profiles with scan peaks, and a preference to, by default, categorize scan peaks above a certain threshold to certain devices. To certain scan peaks, rather. We've also talked about the threshold that's now adjustable, which is new to let users have more or less sensitivity to signals that are hotter in the spectrum. We discussed ignoring intermods for certain groups of frequencies in the coordination workspace and how that has a connection to where your systems might be and how close they might be. And then we also briefly discussed how that's related to zones and when you might want to use zones a little bit. We finished up with a coordination order customization that can be done just by drag and drop in the interface. So those are 3 kind of big feature clusters that 6.12 will have to better enable frequency coordinators to get more frequencies.
Great. Cheryl, what about some questions? Have we got some questions that we want to answer?
We do have some questions. Let's start here at the top. I scan with my UR4D Plus. Is there a way for me to save those scans for a later use?
It's a great question. Yes, there absolutely is. So I'm actually not connected to any network devices right now, but what you can see on the left-hand side here in the frequency coordination view is basically this scan management panel, and each one of these bins is a bin in which I can manage scans differently. So right now, I've loaded a scan file. You can tell because it's in the scan files bin. If I were connected to networked gear, as you probably did with your UHFR, you'd click the gear, you'd find the device that you wanted to scan with, you'd check it and start scanning. And when that scan was done, you can actually right-click on the scan, or as I'm doing here in the scan file, and actually save it as a scan file. So it will prompt you to enter a name, and you could save it as a file, which could then later be recalled by doing something like this. If you click on the folder icon, I can pick here's my wonderful file structure. So I just loaded a secondary scan. Here it is right here. But once you'd save that scan, having taken it from your live device, you could then open it later with this guy here.
Great. Okay, with respect to generic devices, can you give examples of devices that can be ignored or treated less conservatively?
This is very much like it's a thing that you kind of have to decide for yourself. You know, we've got some pretty rigid technical descriptions of how those profiles are generated, but it's very much a subjective thing that you would need to decide for yourself. Do you have any comments on the profiles, Ilya?
Maybe just guidelines, not a rule, but if your generic device is something you believe is preventing you from achieving the count of frequencies you need, consider what that device is. Are you threatening that device by your system, meaning do you want to be a good citizen or you're willing to interfere? Maybe that device is far away and it's just higher power and there is no chance your microphones will ever impact its functionality. That would be a good case to go from a generic device to a generic exclusions, and which will give you more space. As far as IMD source or not IMD source, only a guidelines is to think about the distance. Actually, if the power is high and distance is short, there's a high chance of creating intermod products that could be harmful. If the distance is great and the power is less, or that would be the key to probably say this device is not an IMD source, which gives you even more spectrum back. But those are just guidelines, and it's subject to a lot of experiments and pretty much an experience.
Yeah, and I think just to add to what Ilya mentioned, as a basic rule of thumb, if you want to be a good citizen and not put frequencies too close to any peaks that you scan and detect in the spectrum, use a generic device profile. If you need to be more aggressive, the generic exclusion profiles might step on or potentially interfere with those scan peaks, whatever they might be. But the more aggressive you can be, the more frequencies you're going to find. So it's really a subjective call to make given the circumstances.
The only go-through I would actually state would be you want to achieve maximum count of frequencies with the minimum number of roux relaxations. Since our wireless workbench starts by default by being conservative and giving the greatest protection you can get, every time you relax a certain roux, you potentially increase the risk of interference. So using the broad steps like lowering your compatibility level from standard to more frequency could endanger functionality. So if you can take smaller step and doing it system by system and still achieve your count, that would be a better scenario than just achieving the number while sacrificing the quality.
It's just a good example of how Wireless Workbench might be different in its default configuration from some other coordination software. We take a conservative approach. We want to make sure that any coordination that you get out of our software by default is going to work, and it's going to work well. And there are different frequency coordination applications out there that take a different approach. They are in a more aggressive configuration by default. So the hope is for some of these features that we've added to 6.12 to give savvy users the latitude to be able to get into that aggressive configuration to find those high-frequency channel counts, though the default configuration is still just as conservative as it always has been. And that's just to protect people who either aren't as savvy or have the luxury of clean enough spectrum that they can find clean frequencies.
Great. How do you determine the appropriate threshold for a scan peak detection?
Another great question with a desperately subjective answer. It really depends. The adjusting these thresholds, I think we kind of view them as like Hail Mary sort of. They're things you can do and they're reasonable to do in certain circumstances. But for us, I think from a practical standpoint, when we experiment, it's the last lever I would think to pull.
Yeah, it's not a frequent lever you would use on regular basis. But generally, it's really about knowing your RF equipment down to fine details. That threshold basically tells that if you put a 60 dBm energy into your receiver, and actually you put two frequencies, 60 dBm, close enough to the receiver, your receiver may actually see not only those two frequencies, but also an intermod products. So it's a function of your receiver, it's a function of your transmitter, and it's really a hard thing to assess or give a clear guideline.
I mean, yeah, speaking practically, just looking at the screen right now, I've got TV channel 40 is basically excluded predominantly because of the DTV bump that the scan has caught. I could raise my exclusion threshold such that most of that spectrum is clean. But exactly as Ilya mentioned, I would only do that if I felt confident that whatever wireless system could be parked on top of that DTV station could sustain transmitting on top of it. Not that Shure would recommend doing that, but just speaking practically, that's what you're going to go up against. A DTV station that, by the perspective of the receiver, is being picked up at, let me use my snap cursor to plot here, roughly negative 77 dBm. So it's a thing you got to judge for yourself, but push come to shove, a lot of coordinators will by all means increase that threshold. And the same with the scan peak threshold, I imagine, in the future as well, just because they've got the receive strength at the receivers and their transmit power is appropriately set such that the signal flow is strong enough they can weather through some potentially high noise environments like this.
Great. Can you save the exclusion activity settings without them getting wiped out on the next update scan?
Can you save the exclusion settings without them getting blown away on the next? Yeah. So
actually, yes. There is maybe not a straightforward way, but definitely there is a way. Under the first tab, we have additional exclusions table. Right here, you're looking at it. So every time the scan is processed, the data is populated into this table. As you can see, the 5th column that says source, it says detected. If you want to make it frequency that doesn't get wiped out on the next scan load, you make it that frequency as your frequency. So you double click on detected and
we can't change it. I think if you were to modify the profile or make it something that it was user specified, it gains this new status called user defined.
You make it a user defined. So user defined will be preserved next time you reprocess scan data.
There is an interesting relationship between the way that this table gets populated and the way that you would manipulate some of the preferences that we said before. And I think this is a great question because users who are often tweaking these thresholds would find that that this data, these exclusions, are all shifting, constantly shifting, right? In case it's not clear to everyone, the data that we see in this table here is exactly the same data, equivalent data, to basically these these blue heavenly bars coming forth from the scan data and scan peaks. This is just a tabular interpretation of the exclusions generated from scan data. And so what the question submitted was, well, if I like this data or if I want to preserve this, how do I make it not change if I'm tweaking other things? Another potential workflow might be to export the scan exclusions as they are in a particular state to a file, just so that there's a known snapshot of exclusions in a state. And then if for whatever reason they change, you can always clear everything out and load it. But the reason that they change, and I think I understand that it can be frustrating, and there's probably some enhancements we can make to make it less frustrating, but just so that you know why it's working that way. The sort of main workflow through loading scan data and having exclusions generated is tied up in this functionality of automatically detecting exclusions and scan peaks above thresholds in the coordination plot. It's this thought that I can load scan data and right off the bat in no time flat, Workbench gets a really good vibe of the spectrum and can make some pretty quick assumptions accurately, or hopefully accurately, about what's in the spectrum and where is a good place to put frequencies. So if you didn't want that behavior to automatically occur because you're making changes and you don't want all your scan data to be blown away, you could disable this feature. And then in exclusions, if I wanted to clear everything, I'll clear everything here. And then let's say I wanted to very particularly set up my exclusion thresholds in a way that I thought was appropriate. You'll notice all the blue bars went away. What I could do now is in this dialog, I could manually say whatever the scan data is in its current configuration, both scans and thresholds. If I check scan data now, what it does is it takes all that data in a static snapshot, but it won't be changing every time I move a threshold because that automatic preference that I just unchecked is now disabled. So now you'll notice all my scan peaks are there, but if I move this stuff around, you'll notice that the exclusions don't update, the scan peaks don't change, everything is a static snapshot. So that might be a good workflow for people who want to crystallize their exclusions for a particular point in time. That's a great question.
Great. Can different mics within the same band be assigned to different zones?
Yes. So we're in a two-zone scenario here. I've got UHFR H4. If I wanted to, I could have something in my inventory and pull UHFR H4 into this zone as well. I could just add a fictitious frequency. Sure. Man, we make a lot of devices. Where is that guy? Where is it? Oh, there he goes. UHFR H4, and I would just make sure to add them to zone 2, and I could add primary frequencies, I could add backup frequencies, I could add whatever I want. This is a new little quick frequency addition form that's new to 612 as well. I believe that's what the question was, right, Cheryl? Can
Yes.
frequencies of the same type and band be in different zones?
So you don't have to say all my H4s are in zone 1, all my all my J5s are in zone 2.
That's
Okay.
correct.
Great. Oh, here's a question for me. Will this webinar be available to watch again? Yes, if you go to shure.com/training, it should be posted up there sometime next week, along with all of our past webinars. So next question. What model of scanners work best with Workbench?
Those with Shure written on the front of them. No, it is a good question, and it's a practical question.
Because if you scan with using our wireless systems as the receiver or the tuner, you're limited to the available bandwidth of that device.
That's exactly correct.
But for some users, you might want a whole spectrum scanner.
Yeah, so if we talk from the easiest workflow to the most complex workflow, the easiest way to get scan data into Workbench is with a networked Shure device like a wireless receiver or an Axion Spectrum Manager. And the reason it's easiest is because you can connect the thing to Workbench and start scanning, and there's a live connection where the data just gets sucked in straight away. If you don't have those devices, or as Chris mentioned, if you want to capture scan data beyond the tunable bandwidth of your device, there are a number of third-party devices that can capture scan data and save them as a file that can then be imported into Wireless Workbench. Shure doesn't explicitly endorse one manufacturer or another, although we've heard a lot of reports from users that devices like the TTI, the 2700 model, or RF Explorers, or even higher power RTAs like Anritsu or Rodian Shorts, these are all scanning devices that can generate some form of scan file that's in a CSV format, and that's really the key requirement for us. It's a pretty rigid format that we can accept. It's a CSV format that...
It's a comma-separated value, very common to many manufacturers, and it's universally simple.
And the data in the file that we're expecting is, I believe, frequency and dBm. In the Wireless Workbench help system, there's a page that explicitly states the format that the data can be in. In a future version of Workbench, we could probably make it easier to get a variety of different formats in, but just as a note, WinRadio scanners also export a proprietary format, and we can manage those as well in their native state. But in general, if you can get scan data in a CSV file, it might take a little bit of Excel wiggling to get the data to agree with Workbench, but that would be a way that you would be able to import a file. And you would import it through the exact same workflow that we imported a file previously, just with that with the folder button right there on the right-hand side, or the left-hand side.
I would like to give a little support to Sam's initial statement that the Shure Gear is the best to use as a scanning device. And it's a totally objective reason, because Shure devices, for instance, UHFRs, have the same vision of the spectrum as your actual UHFR devices. So essentially, if your majority of your devices is represented by a certain type, like UHFR or Axion, it's very practical to use the same type of a device for scanning, because it will see the spectrum exactly the way the device, the receiver itself, will see the spectrum. On contrary, if you use a third-party device that sees the spectrum in completely different fashion, and probably the most relevant parameter is the resolution bandwidth, if you can find it on the data sheets, then the vision of the spectrum of the scanner will be radically different from the vision of the spectrum from UHFR or Axion device. And that will introduce a certain inaccuracy in the coordination. By no means it prevents you from doing coordination, but you should be aware that a little inaccuracy will actually occur.
And I was just going to add, that also brings up a point you've made once before, I think, Sam, that it's not a bad idea to be using a similar antenna setup during your scan as you're actually going to use during a show.
Yeah, that's a great point, both you guys. I think to have a scan from ideally the antenna system that all of your wireless systems are going to be using during the show is the most accurate perspective of what your systems might hear in terms of interference or intermodulation or anything like that. And the only caveat I would say to that is when performing like a site survey, maybe at the beginning of the day, right when the gear comes off the truck and you're loading things in, I've heard a lot of users take scans with probably omnidirectional antennas at that point with their own sort of RF chain that doesn't necessarily run through the whole RF signal chain that your rack might have, just to survey what noise could be coming from any possible direction. So during the show, if you've got directional antennas pointing right to stage, maybe it's okay to monitor the environment from that limited perspective. So it really depends the context. But yeah, you're right. If you use the same signal chain that your receivers hear, the scan is going to reflect what they would, what they would hear, what the receivers would experience themselves.
Mm-hmm.
Well, speaking of our old friend, the Spectrum Manager, will there be a firmware update for it to reflect the newer wideband range mentioned earlier?
It's an excellent question. The answer is no, and the reason is pretty simple. The circuitry in the box physically limits it to scan the ranges that it can. So we could firmware update that thing to our heart's content, but nothing will unfortunately extend its scanning capabilities. That being said, the Spectrum Manager does support keeping track of frequencies in a CFL or a compatible frequency list that go beyond its capability to monitor and to listen to, and any interface that shows you frequencies that the Spectrum Manager is keeping tabs on will indicate that it knows about that frequency, it just can't tune in to listen to it.
Great. All right. Well, we still have a lot more questions, but unfortunately, we are out of time, so we're not going to get to that question about the FCC Spectrum auction.
Well, I can give the short answer is that it's still going on.
Exactly.
It's not done. We're planning to have some kind of a webinar about that probably October or November when we have actual data.
Once we know what we can say, we will say it then, we promise you. But in the meantime, that wraps up for today. We wanted to thank you so much for joining us. We hope you learned a little bit, and we hope to see you next time.